You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening, wherever you are. We are coming to you from Boston, Massachusetts. Today is January 24, 2024. Hope everyone is doing well and staying safe. It is going to be another solo episode for me. I do have a guest, an interesting guest for us to learn more about a technology that's becoming really popular. But it's just me for the news and key takeaways today. So let's start by talking about what's happening in the cloud native ecosystem. Let's start with an open source tool from Red Hat that got accepted into CNCF as an incubating project. The project is called Kraken Chaos. And Kraken is spelled weird, but that's how it's pronounced. Kraken Chaos is a chaos engineering tool specifically built for Kubernetes to improve its resilience and performance. There are since it's a chaos engineering tool, right? There are certain test scenarios that you can run against your cluster to verify that your applications will perform as you expect when they're running in production. So some of these test scenarios include things like disrupting application pods. That's pretty simple. But then advanced use cases like sending specific kill signals to mimic failures, terminating nodes, stopping the node, stopping the kubelet running on a worker node, blocking ingress or egress traffic, consuming or hogging up the CPU memory and IO resources on a specific node, filling up a persistent volume to a specific percentage that you specify, introducing packet loss and bandwidth limitations, and many more features. Personally, I'm excited because some of these things do sound interesting. I want to test this out, and I'm glad that they donated it or made it part of the CNCF list of projects. I guess looking forward to seeing a sticker of this project at the next KubeCon, right? That's what these projects get, in addition to all the other things. Next up, continuing the thread to talk about Red Hat. Red Hat Developer Hub is officially GA or generally available. It was announced last year in I think May when Red Hat Summit was at one of the Red Hat Summit keynotes. It's based on the open source Backstage project, but it adds like a self-service dashboard, standardized software templates, a role-based access control, and ongoing support. One thing that popped out from the release notes is dynamic plugin capability, which makes it easier to install, update, and remove plugins from the Developer Hub without having to rebuild the Backstage environment. So go check that out if you have a Red Hat subscription or you're running an OpenShift cluster. This will just work on top. Next up, Trilio, a vendor in the Kubernetes data protection ecosystem, announced support for protecting applications that are running on OpenShift, but those OpenShift clusters can be running on IBM Power systems as well. So not just your Intel-based OpenShift clusters. Even if you're running it on IBM Power, you can use Trilio's data protection tool to protect your containerized or stateful applications running on top. And then finally, we do have an acquisition to share. Sneak, the Kubernetes security and developer security company that personally it's really well funded, acquired a smaller startup called Helios for an undisclosed amount. Looking at Helios's funding history, it seemed like they only raised a $5 million seed round back in 2022, and there weren't any other funding rounds available. So I think this is just a great exit for anybody who invested in the seed round. Sneak definitely is growing at a rapid pace and getting widely adopted. So this just adds to their portfolio. Helios, right? What it does, Helios helps developers troubleshoot and understand their microservices based applications in production. So what Sneak will end up doing is, according to their press release, they'll integrate features like the end-to-end application delivery service that Helios has, and Helios's open telemetry based runtime data collection tools. And both of these capabilities will be integrated into the Sneak app risk product. So if you're already using that, expect these capabilities in the near future. But congratulations to everyone at Helios and Sneak. this just means that there are different exit routes available for startups in the ecosystem, right? With 2024, we want to see either more mergers and acquisitions or more IPOs rolling around. We have a lot of startups in our Kubernetes ecosystem that are ready for the public markets to open up and have some exit for the early employees. With that, let me introduce the guest and topic for today. We're going to talk about vClusters, and it's a really cool technology that offers multi-tenant capabilities for your Kubernetes cluster. And to talk about that, we have the co-founder and CEO of Loft Labs, the company or the startup behind vCluster technology, Lukas, who will join us, and we can ask him more questions about how vClusters actually work. So without further ado, let's bring Lukas on. This episode is brought to you by our friends from Ilotil. Ilotil Luna is an intelligent Kubernetes cluster autoscaler that provisions just-in-time, right-sized, and cost-effective compute for your Kubernetes apps. The compute is scaled both up and down as your workloads demand change, thereby reducing operational complexity and preventing wasted spend. Luna is ideally suited for dynamic and bursty workloads such as dev test workloads, machine learning jobs, stream processing workloads, as well as workloads that need special resources such as GPUs or ARM-based instances. Luna is generally available on Amazon EKS, Google Cloud GKE, Azure AKS, and Oracle OKE. Learn more about Luna at ilotil.co/Luna and download their free trial at ilotil.co/Luna-free-trial. Hey Lucas, welcome to Kubernetes Bytes podcast. Can you please introduce yourself for our audience and tell us more about what you do at Loft Labs?
Yeah, absolutely. Thank you so much for having me. My name is Lukas. I'm the CEO and one of the founders here at Loft. And, our, claim to fame at this point is our open source project, vCluster. A lot of people are actually more familiar with the name vCluster than they are with the company behind it. But yeah, Loft is the company behind it.
Yeah, I think that was my first introduction to Loft as well. Like I found out about vClusters, and then I saw vCluster by Loft Labs. And I think since you also have like a different website for vClusters, it feels like its own thing.
Yeah, okay, we're definitely trying to give it some independence, as an open source project, there's a community around it, etc. Not everything needs to be commercial right from the start. So we felt like having that clear separation makes a ton of sense.
Oh, I like that strategy. So let's talk about vClusters, right? Like, can you talk about like what are vClusters and how they are helping organizations architect for multi-tenancy?
Yeah, vCluster is essentially a Kubernetes cluster that runs inside a single pod, right? It can also run in multiple pods if you have more complex setups, but in the easiest case, a vCluster is just a pod and it hosts an entire Kubernetes control plane inside of that pod. So instead of talking to your EKS API server, you can now talk to that pod. And there's another Kubernetes cluster inside of there. And the big benefit is you can essentially now create, 100 Kubernetes clusters that all run on the same EKS cluster without having to spin up 100 EKS clusters, right? 100 EKS clusters is very expensive.
It is.
You have a lot of redundancies. Just think about like running 100 times Istio. That's very annoying, right? So we're essentially telling you, how about you run one ingress controller, one Istio, one cert manager, and then you spin up 100 vClusters in these pods, and then you give people access to these vClusters instead of giving everyone their own EKS, AKS, GKE, or private cloud cluster, or wherever you are.
Okay, and I think the way you were describing it, right, it felt like the whole VMs to container description that we had in the beginning, where instead of installing guest OS on each virtual machine, why not for an application that you want to run, why not just package your application as a code and run all of them on the same VM? So you said you can run hundreds of these, and I'm assuming these are CNCF-conformant Kubernetes clusters. Like, how big do the host clusters or the base cluster have to be to support these many Kubernetes clusters?
Yeah, they can be pretty lightweight. I mean, a vCluster in the easiest scenario, right? Like in our kind of like getting started setup, right? You're using K3s as a super lightweight, single binary kind of compiled, Kubernetes distro with a SQLite backing store for that for that vCluster, right? So it's as lightweight as it gets. It's really like obviously you can have that SQLite even in the ephemeral container storage, and you have a super ephemeral Kubernetes cluster, but also, you can provision a persistent volume and have the SQLite in there, which is obviously what we recommend. And I think we have that enabled by default as well to retain the state beyond, restarting the pod. And that's just super lightweight. So it really is like, I think we have like a 0.1 CPU as a recommendation to get started with to start the vCluster, and I think like 100 megabyte of memory. So the footprint is super low to get started with a vCluster. And then obviously, the more load you have on the vCluster, the more applications are running in there. You want to probably bump up these, just like with a regular Kubernetes cluster. You want to give it more resources if the control plane, if the API server needs to reply to a lot of requests, etc. But it's fairly easy to get going and have a lot of vClusters in a relatively small underlying host cluster.
Okay, I see the value, right? Like 0.1 CPU and 100 megs is not a lot of resources to get started with. So like, what does the process look like, right, to deploy these vClusters? I have an EKS cluster running right now. How can I get started with it? And what actually gets deployed inside my EKS cluster to get this vCluster functionality?
Yeah, if you have a EKS cluster already and you have a valid, kube context on your machine, so you run kubectl commands, right? You have access to the namespace, you can deploy things to that cluster. You can essentially get started with our CLI, which is really just in a way a wrapper around Helm for vCluster. So vCluster is really just packaged as a Helm chart. And with the CLI is a little bit easier because it just looks at your cluster and then configures certain Helm values, right? And helps you kind of upgrade the cluster easier. But you can just run vCluster create. And under the hood, what that's going to do, it's configure some of the Helm values. Of course, you can customize them to your liking. There's a lot of config options to tweak your vCluster and set it up however you like it, right? But when you just run vCluster create, we have some smart defaults in place, and it deploys that Helm chart to one of your namespaces. And then, that essentially in that Helm chart, the two core pieces that it has is a stateful set that deploys that vCluster pod with the persistent volume to host the SQLite database, and then a service so that the vCluster is addressable. And then what we typically do is you can either expose the vCluster via ingress to the public, of course, but you can also just connect to it via port forwarding. And that's what we do for like a lot of local clusters, etc., to just get you started. So when you run vCluster create, we actually connect to the vCluster automatically and set it as your kube context.
Oh, perfect.
So let's say you're in an EKS context and then you run vCluster create, it'll drop you into the context of the vCluster. And then you can essentially run vCluster disconnect to disconnect from that vCluster inside context and go back to your EKS context. But obviously you can also use, Docker desktops like Switcher to switch the context, or a kubectl command to switch the context, or I think K9S allows context switching as well. Right? Like whatever favorite tool you have to switch your kube context should work as well.
So you said it deploys a stateful set and a persistent volume and a service object, right? So that's my Kubernetes cluster. And if I'm a developer, can I ask for a kubeconfig file to directly connect to the vCluster, as long as my administrator or whoever has deployed the vCluster has configured ingress properly and I can just access it as without knowing like it's not a full-fledged cluster?
Yeah. We actually have, we put there's a config option you can set that automatically puts a secret inside, that deploys a secret alongside that stateful set as well. And that secret contains the kube config. You can also give us a parameter and say like, set up that ingress with this domain and then put this in the kube config, right? And then it becomes even easier to access the vCluster.
Okay. Yeah, that makes sense. So thinking about like, you deployed your vCluster. What's next? Like, how are the cluster-wide resources handled? I know we started the call by saying we don't want to deploy Istio 100 times. How does Istio know that this is a virtual cluster and the service mesh functionality and the communication function, pod-to-pod communication will still work?
Yeah, that's an excellent question. Because obviously, you still want to use Istio, right?
Yeah.
So do we need to now install it inside the vCluster? Well, then we didn't win a lot, right? Like, I
Yeah.
mean, we won that we don't have to pay for an extra EKS cluster and provision nodes for it. That's already a benefit, and things are a little bit more dynamic, I guess, because nodes can be shared and things like that. But a lot of the benefit comes from actually sharing what we call platform stack. And that's things like a cert manager, ingress controller, right? Or like an Istio, or all these like central components, logging, monitoring, compliance and security tools like OPA, for example, right? You want to centralize them, and certain things you want to make available inside the vClusters. Other things you don't want to make available inside the vCluster. Let me give you an example. So OPA, for example, you want to deny privileged pods. You don't need any kind of OPA policy resources inside the vCluster because the user shouldn't be touching them anyway. An ingress controller is different. You want users to be able to create ingress resources, but you want the controller to live outside of the vCluster and centrally manage it, so that you only need one load balancer IP for that one ingress controller instead of everybody deploying their own ingress controller. What you should actually do in a vCluster is you don't allow people to create load balancer services in the vCluster, and then you deploy one centrally and make it accessible. And the way all of this works is with the syncer.
Okay.
So the syncer is really the glue between what happens inside the vCluster and what happens outside in the underlying cluster. So when you create a pod, for example, inside the vCluster, right, or you create a deployment, right, that deployment has replica number one, and then, one pod gets created. Controller manager creates a pod. That basically just means in your etcd, or in this case, SQLite, right, you essentially just have one more entry in that data store. And then typically next, the scheduler would pick up that pod that's pending now and would schedule it to a node, right, to actually be launched. But in a vCluster, it's different. In a vCluster, we don't have a scheduler. Instead, we have a syncer. And that syncer has two kube contexts. It is connected to the API server of the virtual cluster, but it's also connected to the API server of the underlying cluster. And what it does, it sees that pod that needs scheduling, and then it copies the pod down to the underlying cluster. And now that underlying cluster is going to schedule the pod. And that also means when we're creating that pod, it goes through that mission control loop in that underlying cluster. That means if we have OPA, as I said earlier, in the underlying cluster, these OPA policies get enforced across all your pods, despite them, being created in different virtual clusters.
Okay.
And then what we typically do, we have also a feature that is easily enabled with one flag. It's called isolated mode, which by default sets up things like resource quotas, and it sets up things like network policies to make sure that, for example, one pod from one vCluster can't talk to another pod from another vCluster, because technically they are run by the same cluster, right? So there's cluster internal DNS and like all of that stuff. And you want to obviously lock that down and isolate the vClusters in some extent. But then other things like OPA, you want to enforce it across all pods. And when you look at resources that should be shared, like an ingress controller, you can now enable syncing not just for pods. That's a default thing, that syncing for pods is enabled because that's how you can launch workloads. So we need to enable that by default. But you can also say, I'm going to enable ingresses. And that means the user can now create ingresses inside the vCluster, and they also get synced to the underlying cluster. And that means the underlying cluster can run one ingress controller and can reconcile all of these ingress resources from the different vClusters, because they all end up in the same underlying cluster ultimately.
Okay, and that makes sense. So like deployments, stateful sets, or any of the compute resources gets deployed on the host cluster. Are there any restrictions or limits to the different resource types that can be deployed inside a vCluster? Like, can I deploy my own operators and create custom resources, or it's not supported inside that virtual cluster?
Yeah, you can. That's actually one of the biggest benefits, right? So if you are working on operators today, it's really restrictive to share a cluster, right? Because you're all listening on the same resources. You all have to have the same versions of these resources, right? Like CID management is really hard in Kubernetes. With virtual cluster, the only thing at the bare minimum what a virtual cluster and a real cluster need to agree on is what is a pod, right? So as long as we know that the pod spec is kind of the same, right? Like there's not that many like breaking changes in pods happening, right? There may be a couple of fields being added. I remember, I think about a year ago, ephemeral containers were added to the pod spec, right? And then obviously if your underlying cluster doesn't have that, but you specify ephemeral container inside the vCluster, then the question is, okay, what happens, right? And that means you can't use ephemeral containers if your underlying cluster doesn't support it. But that's very, very few edge cases where actually functionality gets added. And the worst case is that piece is not possible, right?
Okay.
But you can still deploy other pods without ephemeral containers.
Okay.
But all the other logic, right? CRDs and then operators listening on these CRDs and performing operations on that API level, they live entirely encapsulated in your vCluster. There's the possibility of sharing things. Like as I said earlier with the Ingress example, you can have with Istio, their CRDs, you can enable syncing for them, for example. But then if you have one vCluster where somebody wants to roll another version of Istio, right? They could deploy their own Istio if you allow them to do that, right? It's pretty flexible. I mean, we've seen vCluster used a lot for like operator development. I mean, our product itself is like all controllers essentially, right? A lot of CRDs, and we're obviously working in a vCluster as well when we're developing the commercial product.
Gotcha. Okay, so can developers or administrators, whoever is deploying these vClusters, right, select different Kubernetes versions for the virtual clusters while the base cluster may be running? So base cluster might be running 125 or 126, but can I start using 129 to develop my app or test some changes out?
Yeah, you can. So we are supporting 4 different Kubernetes flavors. The default setting is K3S just because it's super lightweight, really quick to get started. And for a lot of like dev, pre-production, CI, preview environments, ephemeral environments, those kind of use cases, it's just perfect, right?
Okay.
When you're thinking about, other distributions, what we also support is vanilla Kubernetes, of course. That's a little bit more heavyweight because you have the different components, right? Not packaged into a single binary. Then we also support K0S, which is Mirantis's kind of like, lightweight flavor of Kubernetes, which may have I think they have some networking advantages over K3S, for example, right? Like that's a couple of improvements that I did on that end. And then I think the other distro that's really interesting is EKS. That's actually something that the AWS team has contributed. I was in one of their live stream sessions, right? Like I think it's Containers on the Couch. I think.
Yeah, I love that.
Yeah, it's a pretty good channel that they got going there on YouTube, and I joined them there to talk about vCluster, and then we talked about the different distros, and we had just added K0S. And then the AWS team added a pull request like a week later. And they were like, we should have EKS supported as well. And we're like, that's so cool, right? Especially because they jumped on it so quickly. That was really fun to see.
But how would that work, right? Like EKS is a managed service. Like AWS is managing the control plane for my Kubernetes cluster. If it's running as a vCluster, is it still supported somehow by AWS? Like, or they're just making sure that you get a flavor of EKS?
Yeah, they have this like open source kind of like, so they had this like really big EKS Anywhere initiative, right?
Yeah.
That's what they're using.
EKSD. Okay.
Yeah, EKSD. I think that's the open source flavor.
Gotcha. That makes sense. That's awesome. Good to see more adoption, right? Like you should jump on like streams for AKS and GKE next.
That's true. Yeah, I need to check out their open source offerings if that would be possible. Maybe a good way to do that. But yeah, it's really exciting. I think we've been exploring the route of like OpenShift and those kind of areas as well. Like there's so many distros, right? I mean, we already got K3S, so like part of like the Rancher ecosystem, I guess, is involved anyway. But we'd love a world of having more optionality with regards to what vCluster you want to run.
Gotcha. Okay, and then I know we were talking about Syncer a couple of minutes back. Can a developer who's accessing a vCluster control what resources get synced down to the host cluster, or that's an admin responsibility?
Yeah, that's for very good reasons the admin responsibility, because we want the admin to be able to say, what is allowed inside, or pretty much everything. What we always advocate for is some people start handing out these they put up, they don't make you cluster admin when they hand out the vCluster, and they put additional RBAC and cluster wide roles. And we typically tell folks, just don't do that. Let people do inside the vCluster whatever they want to do, but make sure the sync is configured so that what you don't want to actually be running in the underlying cluster doesn't make it through, right?
Okay.
That's usually the approach we're taking. So configuring that sync is really what we're seeing as one of the ways to lock down a vCluster. And by default, it's pretty locked down what we actually allow. But then you can open it up to like additional CRDs or additional resources that you want to add.
Okay, and you brought up a good point, right? If I'm deploying cluster level resources, since this is my own virtual cluster, can I create cluster role bindings and cluster roles and those kinds of things? And the syncer will basically stop it from getting configured on the host cluster?
Exactly, yeah. Like when you think about a cluster role or any kind of RBAC, right, that really just needs to live inside the vCluster because that's something that your API server handles, right? So you have a separate API server. It doesn't need to reach the underlying API server. Of course, you could argue, like, what if a pod has a service account mounted and does requests? But yeah, we wire up the pod to also talk to the vCluster's API server, right? So those restrictions would be in place for that pod as well, despite it actually running in the underlying cluster. And then there's certain things that we do want to enable for folks that are not so tricky, that are more tricky, actually. So when you think about network policies, right? And let's say you want to allow somebody to do network policies. As we learned earlier, like networking is something that happens in the underlying cluster, right? That's why we can have an ingress controller and our pods run in the underlying cluster, right? So that IPs are in the underlying cluster, etc. So if we want to allow our tenants inside the vCluster to be able to experiment with network policies, we need to enable syncing for network policies. But we need to make sure that these policies now only affect the vCluster. So what we do is we actually have a standard syncer for this. Like for certain use cases, we develop these syncer mechanisms, so it's super easy to configure and you can't go wrong with them. But there's also ways to define your own custom logic and even write code to extend the syncer yourself. But for this case, network policies, we saw that as a very common case. It's a standard resource in Kubernetes. So we put some effort in getting it right. And what we're essentially doing, one thing that's important to understand, we typically try to not create namespace in underlying cluster. So when you have 100 namespaces inside the vCluster, all of the pods that you're launching get synced to a single namespace in the underlying cluster. So we have to rewrite the names, for example, right? We have to rewrite a lot of things in that process. And with network policies, when you set a network policy on namespace A to not be able to talk to namespace B, what we do is we rewrite that to label selectors. And what we do on these pods is we, instead of putting them in different namespaces, we put them all in the same namespace and then we label them. And we put the namespace in the label, right? And that's how we make essentially network policies work inside the vCluster. Despite not allowing you to actually restrict any traffic on another namespace in the underlying cluster. It's a pretty interesting way to do things.
I know that's a super smart approach, right? Like inside your vCluster, I can have 10 namespaces. They get translated and use labels. Okay, and who's configuring these things, right? Is it by default something that vCluster provides out of the box, or is it something that needs to be configured?
Yeah, so we have a lot of config options. By default, everything just works out of the box, right? You want network policies to be synced, you enable that. There's nothing else you need to do because we already wrote logic for that. But then if you want to tweak logic, you can do that, right? So it's really important that we're super transparent about what happens in these syncers. And that's also why vCluster is open source, right? Like you can see what the syncer does and what really the effect of things is. And we have this plugin interface that allows you with like hooks, etc., to kind of manipulate the process. If you're saying, okay, like I want the network policy rewritten, but I also want certain things to be stripped off. Like, we see that a lot for nodes, for example. One of the questions I always get is like, what happens when I run kubectl, I get nodes? Do I see the nodes, all the nodes on the underlying class? What do I see, right? Like, because the vCluster doesn't have a scheduler, so it doesn't even need nodes. It doesn't, right? That's the point, right? It doesn't need static node assignment. But for some applications that you want to test, you need nodes. They expect to see a node, right?
Yeah.
So your admins can configure to sync nodes into the vCluster.
Okay.
And then you can tweak how they should be synced. So you can, for example, enable show all the nodes from the underlying cluster. You can also say show no nodes, right?
Yeah.
But you can also say show only the nodes that a part from the vCluster is currently running on.
Okay.
Because let's assume your OPA or whatever automatically restricts everything from one namespace. Puts like taints, etc. in place to make sure, or node affinity, right, or node selectors, so that you end up on a specific node pool, right?
Mm-hmm.
Like these 5 vClusters always end on that node pool. And then we would dynamically show you nodes based on where your pods are located.
Okay.
So you would only see those nodes. And then you can also enable obfuscation. And that way we rename the nodes, we change the spec, we show you different CPU and memory than the reality looks like, right? And we do these things. There's a lot of like defaults that you can just toggle on and off, like that obfuscation, right? You can say true and we just obfuscate stuff. But if you want to put your own obfuscation logic in place, that's where the plugins and the hooks come in place if you want to do something custom.
So if you are showing or syncing some of the nodes inside the virtual cluster, can a developer then taint or untaint some nodes, or that's like it's only read only, not like you can modify those?
So typically we only allow read only.
Okay,
that's what we set up. But you can also make the bidirectional works too, right? Like you just need to enable that in the syncer, right?
Okay.
But I wouldn't necessarily recommend doing that.
For sure. No, that was just like a corner case, right? Like what if the developer wants to mess with the system and I don't know, break something or try something
if you want to allow your developer to be able to do that for that specific node pool, that's a way you can do that, right? Okay. But yeah, that's not the typical case we see. We typically see the engineers more detached from the infrastructure, and then the admins taking care of all these kind of things. But there's definitely a possibility, like I think so for example, we've been working with a cloud provider called CoreWeave. They made a lot of headlines, regarding
GPU cloud, man.
Exactly. Yeah. Like they became like the synonymous like term for like GPU cloud. It's crazy. They made a lot of progress in 2023. And, I gave a talk with Brandon, one of their like key engineers there at KubeCon in Chicago. It was a lot of fun, that talk. And, they're really open about the internals of their cloud platform. And what they essentially are doing is handing out a vCluster per customer.
Ooh.
And they have really interesting concept because they realized, GPUs are super scarce, right? So you can't just give everybody CPUs, and like it's also very, very cost prohibitive in a lot of cases. Yeah. So when you have your vCluster there, they have 2 options for you. They have a shared node pool where you can just launch workloads on. And then if you pay them quite a lot of money, then you get a dedicated node pool, right? And for example, for that dedicated node, they may enable that you can set labels there and like you can taint it, right? Like because it's your dedicated node. But obviously in the shared node pool, they want it to be read only. So that's a great case to say they would probably enable bidirectional syncing, but they would put a plugin in place and add the custom logic, right? I mean, obviously I don't know the exact like implementation of what they did on that end. But I would assume that's a cool feature for people to be able to label your own nodes, to taint them, etc. But then make sure that doesn't happen for the other nodes.
I know that's an awesome use case, right? Like if I'm a user for CoreWeave and I want to deploy my apps or containers that need access to GPUs, I can still do shared. And does vCluster somehow work with the NVIDIA device plugin and give you like specify how many GPU resources you can have access to, or as soon as somebody wants to deploy a container that needs a GPU resource, the syncer will find the right node and automatically provision it there?
Yeah. So what the syncer does, so their GPUs are part of a real Kubernetes cluster.
Okay.
And the syncer just syncs there.
Okay.
Right. And then the scheduler and I think that they have a very custom scheduler as well at CoreWeave. That then decides, where does that workload actually get scheduled on, which GPU is used, etc. Obviously, that's internals on there, and then probably above my head, to be honest, how that works on the networking and hardware level, right? Whatever needs to be done on that end. But yeah, they gave us a glimpse in the talk. It was quite fascinating to hear what they're doing.
Nice. Yeah, I need to find somebody, some contact at CoreWeave and have them on the pod as well to talk more about this. Sounds like an interesting use case. So, like continuing around along the vCluster questions, right? Security is like a major concern. I know we spoke about network policies, how they get implemented, but just keeping it simple from a perspective of like CVEs and containers that might not be super secure, how do admins control what's deployed? Or if they're using some open source tool like an Aqua Security, Trivi, right? Can they still monitor all the container images across those 100 vClusters if they're connecting it to their node, the host cluster?
Yeah, they can. So when you're thinking about any kind of tool that scrapes things from a pod, whether it's the image to statically scan it, or if you look at extracting the logs with something like a Datadog, right? Or kind of a monitoring tool to check the metrics, right? What we typically recommend doing, obviously, you could set a lot of these tools up in each vCluster, but again, typically not what you want to do. What you want to do instead is run them in the underlying cluster. So you have like one Datadog running or one image scanner running, right? And then the only difference for you as an admin or for anyone who's has access to this tool to actually get the data and the analytics and be able to query what data is being ingested. The only difference is instead of looking on a per cluster, like you set up your views per cluster, you now set up your views per namespace. And you say one vCluster is one namespace, and it becomes really easy. And one thing that we do is we rename, as I said earlier, we name them pods, and you may want to know also what is the namespace inside the vCluster and what it was the name of the vCluster, right? Where is this pod coming from? And we have all that information in labels and annotations on the pods. So you can just set up your views to be able to filter by labels and annotations rather than by clusters and namespaces, right? And that way you get the pretty much the exact same visibility.
Okay. No, I think that makes sense. Like I can visualize it right now. So like security is one big thing. Another thing, again, this is Kubernetes Bytes, right? We started as a storage podcast. What about storage resources? Like if I'm deploying on EKS and I have the EBS CSI add-on configured on the host cluster, how does storage provisioning work, and how like who owns those resources?
Yeah, that's an excellent question. So typically what you would do is in a regular Kubernetes cluster, just as in a vCluster, you would create a persistent volume claim, right? And that persistent volume claim now needs to be fulfilled, and it specifies like a storage class, right? Obviously, if you want your vCluster to be able to use that storage class, you got to make it available to the vCluster. Similar to if you want your Istio resources, like if you want the Istio CRDs to be used inside the vCluster, well, they got to exist in the vCluster, right? But we also have like mechanisms to initialize a vCluster with batteries loaded resources, right? So when it fires up, these CRDs are present, that storage class is available, right? It's really interesting because you could have 10 storage classes in the underlying cluster, and you could say, this vCluster can use storage class A and B, but these vClusters can use C and D only, right? It's kind of nice to also be able to restrict people that way in terms of they don't even see the others, right? You could obviously do similar things like with OPA, but then people would potentially see these storage classes, but can't use them and find out later, right? It's actually much nicer to say, hey, you can only see what you can use, right? And that way, when you create that persistent volume claim and have it like attached to your pod, the pod gets synced, and you would also enable syncing for the persistent volume claim. And then the underlying cluster has the storage controller that then says like, okay, I see a persistent volume claim. I got to create a PV, right, to actually provision the persistent volume. And then that one gets mounted to that pod that I have, right?
Because it's not really a virtual pod. It is a pod running on the host cluster.
It is a real pod.
Exactly.
So all the mounting mechanism, that's why we're like so compliant, right? Because having syncing as that mechanism just makes things so much easier. Like initially we were piloting things and we were trying around what's possible. And you've probably played around with things like Docker and that kind of stuff. And that just gets so difficult and ugly, right?
I know.
Because you have that performance hit, and you have scalability limits, and a lot of things are not supported, right? So many restrictions, right? And then with the syncer, well, it would be like, just imagine you want to share Kubernetes cluster and you want to have 100 tenants to share it, right? The difficulty today really is you can't, you typically confine people to a namespace, and you got to lock them down really hard in terms of permissions. But then they also want to use a lot of objects. So the complexity is really high, right? In a vCluster, it's really easy. You got to lock down a very few basic resources: pod, persistent volume claim, right? Like, it's not maybe network policy, like
the basic necessities,
resources, right? But you don't have to worry about when they run Argo CD inside, or they test the machine learning framework, or a MySQL kind of controller that provisions databases. They can do that. It doesn't matter to you, right? And they can create namespaces. They can set RBAC. They can add an admission controller in their vCluster. They can do they can add a controller, right? Like, all of these things are possible now. So you're really elevating their privileges, but at the same time, you're reducing the complexity to lock down that environment, right? That's the beauty of the syncing mechanism.
And then you brought up Argo CD, right? And that's one of the questions I had. Like, if I'm following GitOps frameworks or patterns and automating my deployments, how does vCluster integrate with tools like Argo or Flux? Do you have runners or something running on your vCluster that always are looking for information? Or how does it work for CD pipelines?
Yeah. So I think when you're talking about a vCluster, the vCluster itself, as I said, is a Helm chart and is configured with a values YAML, right? So the vCluster itself can be managed with Argo CD, right? And then obviously you can have the vCluster as a regular cluster as a deployment target in Argo CD, so that when you have your application sets or whatever you're creating in Argo CD, right, your applications are going to target that vCluster now instead of targeting the real cluster. And that's just going to work, right? Like, everything that Argo does is going to work, whether it sees it as a remote cluster or Argo itself runs inside of the vCluster. We've seen pretty much everything at this point. I think CodeFresh, actually, their managed Argo offering, they're using vCluster. They're very vocal about this. KubeCon, I think in KubeCon Europe and in Amsterdam, they gave a talk about how they use us in production for their managed offering. It's really fascinating to hear these kind of stories. They actually ran without us. Like, we didn't even know that they were using it in production.
Those are the best customer testimonials, right? Like, you didn't even ask for it.
Exactly. And then we saw the talk on the schedule, and obviously we showed up for it. Some of my engineers didn't get in because it was really packed, right? And I couldn't let everybody in the room. But it was really fascinating to hear that. Typically, when people want to use vCluster in production, though, I do have to say it as a disclaimer, I recommend reach out to us first, because we can probably share some advice, so you don't have to run into issues as you scale up. Right? But it also touches on what we're doing on our commercial product, right? Because for example, our commercial product has an Argo integration. And what it does, it provides you CODs to manage vClusters. It also has a Terraform integration, so you can spin up vClusters via Terraform, for example. We are working right now on a cluster API integration, so you can spin up vClusters with cluster API through the commercial product. And then what the commercial product does with Argo, you can with just one true/false kind of statement in the definition of the vCluster, you can say auto connected to an Argo instance. And that means if a developer launches a vCluster, it automatically shows up in Argo, and we even sync the permissions. So you can say, because like our system is hooked up to your SSO, and then Argo should ideally be hooked up to your SSO. Or Argo can even be hooked up to us, and then we proxy the permissions to your SSO. So we kind of become an authentication proxy and OIDC provider for Argo. But in any case, we know what the users are, and they're the same in Argo and for us. And they're the same groups, etc. And then you can essentially give permissions with our product, and they reflect in Argo, which is really nice. So you spin up a vCluster, and it's automatically available to your teammates, right? That's essentially what pieces of what we're doing in the commercial offering.
Gotcha. And like talking about all of these things, right? All the different aspects. I have two more questions. I think one is like definitely like we can talk about that later. Like what's next for vCluster, but then with the whole platform engineering mindset and inside organizations, right? Do you see people building their IDPs using vCluster or spinning up vClusters? Like how does integration work when it comes to platform engineering?
Yeah, 100%. I think we're, with our commercial offering, we're super enterprisey, right? So we work with some of the largest companies in the world, and
Mm-hmm.
they really have the struggle of, they may already have 200 or 500. The biggest one we've spoke to so far has over 3,000 Kubernetes clusters that they spun
Wow.
already.
Okay.
The scale in the enterprise is insane. And I think the reason why they have that scale is there was no good way to share a cluster before
Yep.
vCluster. So what they did is what the cloud providers were advocating for, just spin up another EKS cluster. We
I
made
know.
it super easy. We're reducing the time, right? And that's all great advancements, right? But it's very, like, a lot of these clusters run idle all the time, right?
Yeah.
Because the resources are not shared, right? Like there's an idle Istio running 500 times, right? Like on a Saturday, right? For
Mm-hmm.
all these dev clusters that they spun up. And that's a big problem. And it's also really hard to tell, is this cluster still used or not, right?
Gotcha.
Like, how do you know, right? Like you can
I
look
know.
at API traffic, etc., but like the Istio is always going to do something, right? So it's like, it's really tricky for us to say like what's inside the vCluster is application specific, what's outside is the general platform, and then sharing that general platform but for all your tenants is just so much more efficient. And I
Gotcha.
think with that model, we really allow platform engineers to build that self-service Kubernetes experience that they want to set up. The scariest thing I've heard so far is, not just the numbers of virtual clusters these guys have today, but where they're heading.
Yeah.
Because they see, when you ask them how many clusters have you spun up last year, you find out, oh, the number of clusters has doubled. It's kind of like, so it went from 200 to 400. And then you ask them what's going to happen next year. And they're like, we don't know,
Yep.
but probably a similar trajectory. And then we ask them, okay, what if you had no restrictions? Would you give, a Kubernetes, would you spin up a Kubernetes
Yeah.
cluster for every developer? And the answer would probably be yes.
Okay.
And then think about a big organization of 10,000 developers. Well, that's a lot of clusters to spin up, right? And you can even take it further. Sometimes we ask, would you spin up a separate cluster for a CI run to get a clean cluster?
There are people who do that. Yeah.
There's a lot of clusters that you have to spin up, right?
Yep.
With vCluster, that's just much more efficient. So like we're really enabling, I think, the broad adoption of Kubernetes for all of these use cases, while reducing the cost and standardizing the way on how to spin up, how to dispose, and how to manage the life cycle of these vClusters.
Gotcha.
And that's ultimately what platform engineers do, right? On the one hand side, they standardize things like an Istio and like access to storage and like all of these underlying things, right? But at the same time, they want to enable self-service and autonomy and velocity.
Yep.
What better way to do that by saying, hey, you can be cluster admin, right? That's essentially what we work on with a lot of these companies.
Gotcha. Okay. So now let's talk about like what's next for the open source vCluster project, right? Like looks like you have most of the areas covered. So like what's coming down the pipe?
Yeah, there's a lot of stuff still in R&D. So I say we're still super early. It sounds like, we definitely put in a lot of work in the past.
Yep.
Like, it's been almost 3 years at this point, 3 or 4 more months. And then we have a 3-year anniversary for vCluster. But, I think there's still a lot of areas that we find super interesting in R&D. One of them is, for example, to snapshot an entire vCluster and move it to a different cluster.
Oh, wow.
Or even a different cloud,
Yeah.
right? That's a super cool idea. Obviously, there's some really tricky challenges, like how do you make, for example, how do you snapshot the persistent data alongside with the application data, right? How do you kind of find the right time to take that snapshot to not be disrupted or have anything corrupted, right? There's challenges in that direction, but that's a really, really exciting thing, because then you can see a world where, when you like the default way to install an application these days is a Helm chart.
Yep.
But a Helm chart is like, that's a lot of images and a lot of containers, and a Helm chart is relatively complex. And And then you have persistent data and a lot of like infrastructure stuff below it. But if I now, you can't capture a state with Helm. So if I have a problem, like let's say I install GitLab on my Docker desktop Kubernetes cluster, and then I run into issues with that GitLab instance. Can I send that to my buddy? No, I can't, right? Like they can install, via Helm.
You have to reproduce the whole issue and
But what if I could just snapshot and send it to my buddy, right?
I know.
And that's really cool. So packing up a vCluster and unpacking it somewhere else allows a lot of these debugging use cases, but also cloud migrations. Let's just say you have GitLab running in this one cluster, and then you're saying, maybe we got to reset that up, and maybe we're going to move to EKS instead of COPS or whatever you used to spin up the cluster initially, right? And then, well, that's a big migration project suddenly, right? What if you could just snapshot that vCluster with GitLab in it and move it to somewhere else, right? That's a really, really cool thing.
These are some interesting use cases for sure. Man, I'm looking forward to, I don't know, I'm going to follow vCluster channel more to see what's going on. Okay, so one question that we have added in season 4, this is our 4th year doing it, right? How are you thinking about AI inside Loft Labs with vClusters? In general, are you... And this answer can vary anywhere from GitHub Copilot for developers to you're actually adding AI capabilities inside the product.
Yeah, I think we're not too close to AI on the application level, but we see ourselves kind of as an enabler for that AI wave. When you think about a CoreWeave, for example, using us to bring more Kubernetes and more GPUs to these AI engineers, I'm very proud that we, contribute to that, success that CoreWeave is having there. But also in a lot of other cases, when you think about, the need for Kubernetes in an organization. Well, if you are running, obviously you can always run like a local kind cluster, Docker desktop, Rancher desktop, any of these solutions, right? But it's probably really hard for you to run like a large language model or train any kind of data on your local machine. So there's suddenly a really big need to be able to get access to a large scale distributed, system like Kubernetes in the cloud, right? But then you have things like EKS, etc., and then you're running into the problem again, like how can I hand out that to everybody, right? And that's where vCluster comes in. It's vCluster can be that enabler either within your organization, but also for folks like a CoreWeave that have like a managed service for others to hand out these resources to folks. So we're a little bit below on the infra layer on the whole AI story. But it's something really exciting for us. And, apart from that, obviously, we're trying out a lot of AI tools ourselves for all kinds of, meeting summaries and knowledge bases and you name it, right? There's so many advances coming out. I think one of the biggest things I've seen so far is automatic summarization of issues. Because people tend to send us really big messages of hey, I'm trying to do this in the vCluster, etc. And then we got to figure out, who do we assign this best to, right? But usually it takes a while and
make the triage process a bit simpler. Yeah,
exactly. Now we can triage based off a summary first, and then have somebody look in a second step, right? Those kind of things are just how we leverage, ChatGPT and other things internally.
Okay, one last question. Where can find people more information about vClusters, getting started, any tutorials that you want to share with our listeners?
Yeah, vCluster.com is the website, pretty straightforward. You'll obviously find the link to the Git repository from there. You'll also find our vCluster Pro offering from there. Obviously, it's linked on that side. And then if you want to join us, we have a very active, in the conversation going on in our Slack community. So you can go to slack.loft.sh. It should also be linked from pretty much any website and the Git repository. But that's a really good address to, if you run into any kind of issues, if you're thinking about using vCluster for a specific use case and you want to see who else has done it and what they would recommend, right? Or obviously, if you want to contribute but you don't know what is the right starting point, well, just join us on Slack. Open up the conversation. It's really vibrant there. We have I think over 2,500 people in that Slack community already, and there's it's so exciting to see. I think right now there's 5 or 6 members joining every day, so it's just growing so quickly. It's really, really exciting. So definitely check out our Slack if you're interested in vCluster.
No,
And we'll include all of these links that you just shared in our show notes as well. So hopefully people can find those easily. But I want to take this time and thank you so much for joining us. Thank you, Lukas. This has been a great discussion. I learned a lot of new things. I'm sure our listeners did too. And yeah, with that, I'm looking forward to having you on maybe in a future episode when you have more features and more maybe that snapshot functionality is working. So thanks again.
Yeah, absolutely. Happy to join again as we go further along in the vCluster journey. It's so great to be invited to Kubernetes Bytes. Thank you so much.
Okay, that was a great conversation. Hopefully, you guys learned something new. I'm sure I did. Let me just do my few key takeaways, and we can wrap this episode up quickly. First of all, vClusters, a great open source project that you can start using today on any supported or any Kubernetes distribution. The thing that I really liked was the really small footprint, like to get started or to deploy a vCluster. The whole orchestration capabilities that vCluster brings to get started, you just need like 0.1 CPU and 100 megs of RAM. That's nothing when you compare it to some of the application resources that are being consumed by pods that don't really need those resources, right? So great way to get started. Test this out in your own environment. I really like that it supports things like OPA, network policies, ingress, security scanning tools, and storage primitives as well. So you don't have to change or adopt new tools just to use the vCluster functionality. You can just manipulate the syncer functionality to see what gets translated or transmitted from the host cluster to the virtual cluster and back the other way around as well. vClusters, but another important thing to note is, like, if developers inside their own vClusters wanted to test resources like operators and custom resources, they have the ability to do that without creating conflicts on the base cluster. Thing that also popped up was different version support for the base cluster and the virtual cluster. So as we discussed in the episode, right, or in the interview, you can have a 1.26 Kubernetes base cluster, but you can start testing out the 1.29 version of Kubernetes as part of your vCluster. And then I really liked how Lukas was able to bring in customer examples like CoreWeave and CodeFresh. Both of those seemed interesting. I'll also link those blog articles and those sessions in our show notes as well. So feel free to make sure you go and check those or read those for yourselves. But I think that brings me to the end of key takeaways for today. Hopefully this was a good episode for you. Thank you for spending the time with us. Make sure to give us a 5-star rating on anywhere where you listen to podcasts. If you haven't already checked out our YouTube channel, you can see interviews on video as well. So even if you prefer the audio format, which I know 90% of you guys do, but feel free to just still go and hit subscribe or like our YouTube channel so we can find new listeners. With that, this is Bhavin, and thank you for joining us for another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.